We're in Module 2, Topic 1, Lesson 4, Connect 4. Compare linear functions in different forms. Let's start with a warm-up. Determine whether each set of ordered pairs represents a function. Explain your reasoning. Remember that a function is where your domain is not repeating, or you could say that exactly one output is matched to one input. I like to look at my x values. I notice that they're all different. They're not repeating, so I have a function. -1, 0, 1, and 2, all different, all unique. You have a function. -1, 0, 1, 2, still a function. -1, -1, uh-oh. Right here, I'm seeing that my domain is repeating, my x values are repeating, not a function. Our learning goals are to compare linear functions represented algebraically, graphically, in tables, or with verbal descriptions. Choose and interpret appropriate units to represent independent and dependent quantities in situations modeled by linear functions. Choose and interpret appropriate scales and origins for graphs of linear functions. You've already represented linear functions in a variety of different ways. How does each linear function representation compare with others? Getting started. Odd one out. Choose the function that does not belong with the others. So I think the directions are a little bit misleading on this one. Let's just take each function and compare it. For function A, I can see that I have a y-intercept at the origin, and it's proportional. My slope, if I do 3 minus 10 and -1.5 minus 5, that's going to give me -7 over 3.5, and then 3.5 will go into 7 2 times. So that'll give me a slope of -2. So I could have an equation as -2x for function A. Function B, it says that during 1 year Belfield High School, the ratio of boys to girls is 1:1. So we could say that y equals x there. Of course, this has a positive slope. This has a negative slope. Function C, here we have a positive slope. Function D, I can see that my y-intercept is 5. My slope would be, looks like it crosses there, 1, 2, 3, 4, 5 over 1, so 5x plus 5. So there's things that they have in common, and there's things that they have different. Here we have a positive slope, a positive slope, a positive slope. Function A has a negative slope, so that would kind of be the one that just doesn't fit with all the other ones. Let's keep exploring. Activity 4.1, comparing tables and graph. Large recycling centers pay out different amounts per ton of cardboard recycled. Washington County Recycling Center lists its payout amounts in a table, and Jackson County uses the graph to advertise its payout amounts. The two centers' payouts amounts are close but not equal. So let's label the table. For Washington County recycling, our left, our independent, would be the weight of cardboard. And that's in tons. So we start out with a half a ton, 1 ton, 1.5, and 2 tons. And then the right-hand column will be the payout amount, which will be money. So if you notice, for 1 ton is $15. Let's compare that to Jackson County. So this down here for your X is the weight of your cardboard. It's the tons. Over here on the Y-axis, it's your payout. It's your money. So for 1 ton on Jackson, you're getting paid a little bit more there. You're getting paid $20 for Jackson. So 1 ton equals $20. And for Washington, 1 ton gives you $15. Number 1, it says each representation shows a functional relationship between quantities. Label the quantities and their units in the table. So we did that. Number 2 says let WX represent the function for Washington County, and let JX represent the function for Jackson County, using greater than, less than, or equal to complete each statement. So I'm going to leave my writing on here because I'm going to be going back and forth here. So for half a ton for Washington County, let's go back up here and let it line up. So for half a ton, it's $7.50. For half a ton for Jackson County, it's $10. So let's see, Washington County was $7.50. Jackson County was $10. So that is less than. And then for Washington County, we already looked at that was $15. And for Jackson County, that was $20. So it's still less than. And I'm going to scroll back up and look for Washington County at 3 tons. It doesn't say what 3 tons are, but I bet we can figure it out. If we see that we are, if my rate is 15 minus 7.5 over a half, 1 minus 0.5 would be a half, and 15 take away 7.5, and a half goes into 7.5 15 times. So my slope is 15, my rate is 15, which I could have seen that there. My rate is 15. Here my rate is $20. So to answer part C, if I have 3 tons, 3 times 15 gives me $45 as my payout. And then for Jackson County, 3 times 20 gives me $60. So still less than. Number 3, compare the y-intercepts of each relationship. What does each y-intercept mean in terms of the relationship between the quantities? So let's look at the y-intercept. The y-intercept is where x is 0. So when I have 0 here, my y-intercept, let's see, I figured out that 15 was my slope. So y equals 15x plus b. And I'm going to pick a point. We can pick this point here. And let's say that $15 is my y, 15 times 1 plus b, so that does give me 0, and which would make sense. So my y-intercept is 0 because if I'm not taking any cardboard, then I'm not going to get a payout. Same thing here, my y-intercept was 0 in both situations. So both y-intercepts are 0, no cardboard to turn in, no money to get in return. Number 4, which recycling center would you choose? Provide evidence to justify. Well, if you remember, Jackson County had a bigger payoff. Its rate, its slope was $20 per ton. So I definitely go with Jackson because the rate over here was $15 per ton. Activity 4.2, comparing equations and tables. Josh and Greg are friends who live in different countries, and when they chat online and talk about the weather, one of them always uses temperature in degrees Celsius while the other talks about temperature using degrees Fahrenheit. Josh uses an equation to convert Craig's temperatures, and Craig looks at a table to convert Josh's temperatures. The equation and part of the table are shown. Number 1, identify the quantities in the table and the equation. Who's converting from Celsius to Fahrenheit and who's converting from Fahrenheit to Celsius? Explain your reasoning. So this little remember tip kind of helps to figure out that in Craig's table, this would be your or if I plug in 0 for Josh's, then that would give me degrees Fahrenheit. So Josh has Celsius. To Fahrenheit. Craig has Fahrenheit to Celsius. Number 2, compare the given characteristics for each function in terms of the quantities, the slope and the y-intercept. So he said this was Fahrenheit and this was Celsius. So the slope in both situations is 9/5. The rate of change for Greg's table is also 9/5. for every 9 units of Fahrenheit, you go over 5 degrees of Celsius. Your Y-intercept is a positive 32 in both situations. So, the 9 over 5 is the slope for Josh's equation. 32 is the y-intercept for Josh's equation. Let's look at Greg. The slope for Greg, negative 1.1 minus negative 12.2 divided by 'So for Greg's table, we notice that we're supposed to come up with something of 5 over 9, the reciprocal of Josh's slope. We get close. So the slope is supposed to be 5 over 9. The y-intercept for Greg's table is negative 17.75 degrees Celsius. For 4.3, compare descriptions and graphs. Michelle and DeAndre both opened bank accounts at the same time. DeAndre's account balance is shown in the graph. He started at 0 and deposited the same amount each month. In the 4th month, he had $80 saved. Michelle opened her bank account on September 1st with $25 and continues to deposit $25 each month. Use what you know about DeAndre's account to determine the scale of each axis and interpret the origin on the graph and explain your reasoning. All right, so DeAndre opened his account with 0 and he deposits 80 each month. So I'm going to say that this is my 1st month, this is my 2nd month, this is my 3rd month, and this is my 4th month. So here this is going to have to be 80, so I'll say this one is 40. And we'll go up increments of 40. So this will be 120. And so this one will be 160 and so forth. So your X will be your months. And your Y is going to be your money that he's deposited. I'm sorry, I misread that. He had $80 in the 4th month. So in the 4th month, we've got 80 all the way up here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So that means we can go up by 10. So that'll be $20 for each month. 30, 40, 50, 60, 70, and 80. Number 2, compare the given characteristics for each function in the terms of the quantities. Okay, so we need to talk about the slope and the y-intercept. All right, I'm going to keep DeAndre in blue. So my slope is I'm going up 10 over 1. I'm sorry, up 20 over 1. So my slope is 20. Michelle deposited $25 each month, so her slope is 25. However, she starts out, her initial fee, her Y-intercept is $25. So her equation would be 25x plus 25. Andre would have y equals, or f of x equals 20x. Talk the talk. Function maker space. Consider the table of values. Create a situation to represent the table of values shown. So let's see. Lots of things we could come up with here. Looks like I owe somebody $10, and then I eventually pay them back, and I'm keeping some money and I'm earning some money. My rate here would be, let's see, 10 minus negative 10 over 5 minus 0. So it'd be 20 over 5 gives me 4. So I could be making a situation where I'm making $4 per hour. Maybe I'm babysitting, maybe I'm tutoring, and I owe somebody $10, so I paid them back, and then I start saving some money. Write an equation that has a slope that is less steep than the relationship in the table. Less steep. Alright, so I've got a relationship of 4, so I could say that y equals, or f of x equals 2x plus 4 or plus 0, and that would be less steep or smaller than 4. Number 3, how does the slope of the graph compare to the slope of the table of values? So before I had a slope of 4. Now let's see what my slope is. 1, 2, 3, 4. See, so I'm going up by 1, and I'm going over a slope of 3. So my slope here is 1/3. How does the slope in the graph compare to the slope of the table of values? So it's certainly not as great. Certainly not as steep. No, let's go back here. I'm getting too quick on these. My slope is the second y minus the first y over the second x minus the first x. I gotta take the difference of my y's first. So it's 5 minus 0 over 10 minus negative 10, which is 5 over 20, which is 1/4. So I have a slope of 1/4. So I could say that I'm reading a book, and I could say x is in minutes. Every 10 minutes I'm reading, I don't know, 2.5 pages. A lot of things that we could say here. Number 2, write it something that has a less steep of a slope. So I can say what's smaller than 1/4. 1/3. Nope, that's bigger. 1/5. That has a less steeper of slope. let's go down here to the graph. The graph, we did it, right? It was 1/3. So this 1/3 is, if you think about 1/4, 1/4 1, 2, 3, 4. And you compare the blue line to the black line. The black line is more steep, so it's steeper than 1/4. Number 4, what strategies did you use to create your linear functions and compare the slopes? Well, for my slope, I just did rise over run. I went up 1 and my rise was 3. In the table, I did my slope formula as my second y minus my first y over second x minus my first x.